millions. It will be outbid. If it had bid 10 million, it would have won, and it would have had a nice 2 million profit, 10 million minus 8 million. So underbidding is never advantageous, and furthermore, it runs the risk of losing the license altogether. So you don't want to underbid in this kind of mechanism. Similarly, you don't want to overbid. You don't want to overstate because, again, it's never going to be advantageous to overbid. If the second highest bid is 8 million and you bid 12 million rather than 10 million, you'll win either way, 10 million or 12 million, and you'll pay 8 million in both cases. So bidding 12 million doesn't have any advantage. Furthermore, you run the risk of overpaying, because now if you bid 12 million and there's another company that bids 11 million, well, you will win, but you will end up paying 11 million, and that's a higher figure than the license is actually worth to you. It's worth 10 million to you. So by overbidding, you might end up paying too much. So you don't want to overbid either. And that means that the only thing left is to actually bid exactly what the license is worth to you. And if companies realize this, if they go through the kind of logic that I just went through, they will bid what the license is worth to them, and therefore the winner will be the company with the highest value, which is just what the government wanted in the first place, even though the government didn't know which company that was. So this is, again, a very clever and very economically important example of mechanism design in action. This kind of logic was very important in designing the auctions, the selling procedures that have actually been used in privatizing the radio spectrum. Okay, so that's our second example. Let me look at one more example, and then I will wind up. And this final example is going to be an energy example. So let's imagine that we have a society with, it's a very small society. It'll just consist of two people. We'll bring back our friends Alice and Bob to populate the society. And Alice and Bob are consumers of energy. There's also an energy authority which is going to choose a source of energy from which Alice and Bob will get all of their energy needs. They will satisfy all their energy needs from this public energy source. And let's suppose that there are 4 alternatives that the energy authority could choose from. It can only choose one of these. It would be too expensive to have 2 different kinds of energy. But the 4 it considers are first gas, oil, nuclear power, and coal. And of course, what it would like to do is to choose an energy source which is good from the point of view of the consumers, Alice and Bob. But the whole difficulty is that the energy authority doesn't know what Alice and Bob actually want. Let's imagine that there are 2 possibilities. I'm going to look at a very simple example. Let's suppose that there are just 2 possibilities for what Alice and Bob might want. We'll call them 2 states of the world. In one state of the world, the first state, we'll suppose that Alice and Bob care mostly about their current consumption. They don't put too much weight on the future. And in the And in the other states, state 2, they put most of their weight on future consumption, not so much on the present. Now, how does that translate into their views on energy? Well, we'll imagine that Alice, when consuming energy, cares mostly about how convenient it is to use. So that means that in state 1, where she's putting most of the weight on current consumption, she likes gas the most because that's the easiest to use, then oil, then coal, and nuclear power comes last because that's the most cumbersome. In state 2, where she's looking ahead to the future and she cares about future consumption, now nuclear power comes up at the top because she anticipates that there are going to be technological breakthroughs which make nuclear power much easier to use in the future. We'll suppose that Bob, in contrast, cares mostly about how safe the energy is. So in state 1, he puts nuclear up at the top. He feels that's the safest. Oil is next, then coal. Gas is down at the bottom because he's worried about gas explosions. He's worried about his oven blowing up. In state 2, where he's looking ahead to the future, now nuclear goes down to the bottom because he is worried about the long-term problem of getting rid of nuclear waste. So really all I've been doing is telling you a story about why Alice and Bob have the particular preferences they do in the two states, and I've summarized their preferences here. So in state 1, these are Alice's preferences. Alice puts gas up at the top, then oil, coal, nuclear is down at the bottom, and similarly for Bob, and similarly for state 2. And what the Energy Authority would like to do is to choose an energy source which takes into account both what Alice wants and what Bob wants. Let's say the Energy Authority would like to compromise between what Alice wants and what Bob wants. So that suggests that in state 1, oil might be a good choice because, gas is not a good choice because although Alice likes gas in state 1, Bob doesn't like gas at all. And although Bob likes nuclear power, Alice doesn't like nuclear power at all. So gas and nuclear are not a good choice. And coal's not a good choice because both Alice and Bob prefer oil to coal. So that leaves oil as the right compromise in state 1. And similarly, gas is the right compromise in state 2. I've set up this example so that state 1 and state 2 are very symmetric. So basically anything I say about state 1 can be translated into a similar statement about state 2. The problem, of course, is that the authority doesn't know Alice and Bob's preferences. It doesn't know the state. It doesn't know whether this is true or this is true. So it doesn't know whether to choose oil or gas. Now, how can it solve this problem? Well, again, the most straightforward mechanism would be for the authority to just go ahead and ask Alice and Bob, what is the state? What are your preferences? The problem is that